Hi, good morning, everyone. Good morning. Anyone here who was not here last week? Are you new? Can you please ask for a tune on the back of his head? Good morning. Good morning. Right, guys, are there any questions for homework? Yes. What is the question? $15. Didn't we do 4? Oh, we did the fourth one, is it? We have to do 4 part C. 4 part C is a question for homework, correct? Okay, let's start with that. Question number 4 part C. In a game of snooker, a white ball and a black ball of equal masses are on a horizontal table. A player hits the white ball, which then moves with velocity of 1.2 meters per second before colliding with the black ball. The player hopes that the collision will knock the black ball towards the pocket at the corner of the table as shown. After the collision, the velocity of the white ball was at 35 degrees to the original path. Did you get that too? Right, so the question, we answered the part A and B. Part C is, deduce whether the black ball moves towards the pocket. You should use a scale vector diagram. Okay, fine. Guys, before the collision, the total momentum is, the white ball has a momentum of, its mass is, if I take it as m, before the collision, the momentum is m into 1.2. m into 1.2, that is 1.2 m. That is a collision, that is the momentum of the entire system before the collision. Correct? After the collision, the momentum of the white ball is 0.92 m. 0.92 m. Its mass is m. Velocity is 0.92, so it's 0.92 m at an angle of 35 degrees. Okay, this is the momentum of the white ball. So the momentum of the black ball is, do we know the speed of it? No, we don't know. We don't know the angle as well. So I'll take it as mv, its velocity is v, the mass is m, and this angle also we don't know. The angle is, I'll take it as theta. Am I right? If this theta is equal to 50 degrees, that means yes, the black ball will go in the direction of the pocket. Agree? The question is what? Deduce whether the black ball will move in the direction of the pocket. Will it move towards the pocket? So you should use a scale vector diagram. So if you can show that it is moving at an angle of 50 degrees, if you manage to show that the theta is 50, then correct. Right? Okay. Let's try to draw a vector triangle. So now, according to the principle of conservation of momentum, the total momentum before is equal to total momentum after. So the addition, the resultant of these two vectors is equal to the initial vector. So 0.92 m is this one.
Good morning, sir.
Very good morning. And this is 1.2 m. So guys, I'll take a scale of 0.1 m, or 1 m I will take it as 10 centimeters. The momentum of 1 m is equal to 10 centimeters. Okay. So what you do is, this 1.2 m to the right, we will represent it with 12 centimeters. Agree? And this 0.92m, that we will represent it with what? 0.92m will be represented with what? 9.2 centimeters. And this angle has to be 35 degrees. Okay. And then from there, we will represent the momentum of the white ball after the collision. Sorry, the momentum of the black ball after the collision. That will be whatever this point connected to this point. After you do that, let's check the angle. Okay, this is MV. Let's check this angle and see what is this angle we are getting. If you are getting 35 or anything closer to that, that means yes, the black ball is going in the right direction, in the direction of the pocket. Otherwise, no. Understood.
Why is that, sir?
Sorry?
Why is that?
Why is what? Please
Now,
repeat
how
your
come
question.
if it becomes 35, we have to find 50, right, sir?
Oh, wait, sorry, not 35, I said. I mean 50, my bad. It should be 50. 35 was this one, my bad. So check this angle and see if it is 50. Can you? I believe you have your protractors. No? No? Shall I share the protractor? We can calculate it, but the question clearly says what? Deduce whether the black ball moves towards the pocket. You should use a scale vector diagram. Okay. It's not only about getting the answer, it's also about doing it the way they have asked you to do. So use the scale diagram and do it. Now, who are the people having the protractor now? Can you share it with these poor kids who don't know to bring a protractor? So I'll mark this angle theta. You do the diagram and tell me what is theta. Yes, what are you getting? 50? 57? 50? 50 or 50, 51, 52, 53, anything around very close to 50 should be fine, because anyway, when you draw the diagram, it won't be 100% accurate. So if you're getting something close to 50, then yes, you can write the statement saying theta equals 50. Hence, black ball will move towards the pocket. Are you new to class?
Yeah.
What else, guys? What's next? 15. Right, question 15. A student carried out an experiment on momentum using two table hockey pucks as shown. Each contain a small fan so that they collide, so that they glide across the table on a cushion of air. The mass of the pucks can be varied by attaching small masses onto it. In each experiment, the student pushed one towards a stationary puck. In one experiment, the first puck reached a speed of 0.35 meters per second after being pushed for a time of 0.28 seconds. Calculate using idea of impulse, the average force used to accelerate the first puck. The mass of it is 110 grams. Okay. So guys, its initial momentum is 0. It was stationary. So after being pushed for a time of 0.28 seconds, its final momentum will be mass into velocity. Mass is 0.11. 110 grams is 0.11 kilograms. Velocity is 0.35 meters per second.
Sir, they talking about the first puck, sir, not the second puck, sir.
Huh?
They talking about the first puck, not the second one. They are talking about the first puck, not the second one.
Yeah. In one experiment, the first puck reached a speed of 0.35 meters per second after being pushed for a time of 0.28 seconds.
Yeah.
So initial momentum of it was 0. It was stationary. And then when it reaches a time speed of 0.35 meters per second, its momentum is 0.11 into 0.35. That is 0.0385 Newton seconds. So the impulse that has acted will be, impulse is equal to change in momentum. Correct? So the change in momentum is 0.0385 Newton seconds, because the initial momentum is anyway 0. So finally, calculate using idea of impulse, the average force used to accelerate. So the average force will be equal to impulse over time taken, or the change in momentum over time taken. So the impulse is 0.0385 over the time taken is 0.28. That's 0.1375 newtons. That is the force which is used to accelerate the first one. Have you done it? On there last week? Did you go through the recording? Okay. The next one. In another experiment, the first puck was pushed towards the stationary puck with a speed of 0.41 meters per second. The parts of them before and after the collision are shown. The paths are labeled Mach 1 and 2. Calculate the speed of the second one after the collision. The mass of the two are given. The first one has a mass of 110 grams. The second one has a mass of 130 grams. The speed of the first one after the collision is 0.28 meters per second. Okay. Anyone who got the answer? What is the answer? 0.26. Let's do it and check. The first one has a mass of 110 grams. And it's moving at a speed of 0.41 meters per second. After the collision, the first one has a speed of 0.28 meters per second. To calculate the speed of the second one, this is what we want. V is what we want. Okay, so guys, that's an easy one. The second one has a mass of 130 grams. First one has a mass of 110 grams. So we will use the principle of conservation of linear momentum to the right. If we use a conservation of linear momentum to the right, guys, mention this. PCL. What is PCL? Principle of conservation of linear momentum. By applying principle of conservation of linear momentum to the right, the total momentum before the collision is 110 means 0.11 kilograms into the velocity 0.41. This is the total momentum to the right before the collision. Okay. In the same direction, the total momentum after collision will be 0.11 into 0.28 cos 49. That's because the component of this in this direction will be cos 49. 0.28 into 0.11 into cos 49 plus the momentum of the other one will be 0.13 into V into cos 43. Okay, so from here you can get the V subjective. 0.11 into 0.41 is 0.0451. That's equal to 0.11 into 0.28 into cos 49 will be 0.02 plus 0.13 into cos 43, that is 0.095. 0951 V. So from here, if we get the V subjective, 0.0451 minus 0.0202, and then you divide it by 0.0951, 0.262, or 0.26. Good, very good. Those who did it, excellent. And if there are people who just went home last week, kept the book closed, and now came and opened, this is for you. If you continue to do this for another couple of months, you might even quit A2 levels. Okay, you will start hating the subject if you do that. You know that, I don't have to tell you. If you think the AS was challenging, definitely A2 will be a bit more challenging than that. So these subjects are designed for the students who are well organized, and for those students who have a self-discipline and who will follow the process of studying on a daily basis or at least on a weekly basis. If you are just going to come to the class and go home and keep the books closed and come on the next day, trust me, you are just going to waste your time and money. Don't do that. If you don't do any homework, if you don't do the questions last week, at least start it from today. Please don't behave like 13-year-olds. Okay, you have done your O levels, you have done your AS levels, and you have just come to the last stage of your school's education. Don't just take things for granted. Okay, you have the privilege of doing London A levels, means you are already being blessed with what most of the people don't have in this country. Don't take things for granted. Please make use of it. Okay, try to do your A levels well. You don't have more than 90% of the students have problems in this country. You don't have any of those. Okay, be thankful for that. The only thing that you have to do is just focus on your studies. You don't have anything else to do. If you look at the students in this country, the problems they have, you can't imagine. So you have been gifted with so much, and on top of that, don't just stay on a very comfortable bed and sleep. Just get out of your comfort zone and put a bit of effort to do your A levels well. Okay, I can't keep telling this every day. Behave like according to your age. Okay, you have to have that self-discipline. Otherwise, A levels is not for you. Please go and do your O levels again then. If you want to just be lazy and do exams, keep doing O levels every year, not A levels. Okay, fine. Guys, what's next? There's another part, but I don't think I told you to do it, did I? Oh, did you say that this was an elastic collision? What is an elastic collision?
That means in a closed system, the kinetic energy is unchanged. Yeah.
Yeah. So how do we check whether this was an elastic collision or not? Simply you check the total kinetic energy before the collision of the system and the total kinetic energy after the collision. If those two are equal, then it is an elastic collision. Otherwise, no. Right? Fine.
So if it's an inelastic collision, it means it's not in a closed system, right? It means it's in an open system. Or is it in a closed system?
No, it has nothing to do with whether it's a closed system or not. That is about, you're talking about momentum. For the kinetic energy, you don't have to consider that.
No.
Okay. So I'll take the total kinetic energy before the collision. I will take it as E1. The mass is 0.11 kilograms. So half mv square, half into 0.11 into V is 0.41. 0.41 square, that is the initial kinetic energy of the system. Then guys, the final kinetic energy, I'll take it as E2. That will be half into 0.11 into 0.28 square. Okay. Plus the other fellow is having a kinetic energy of half into 0.13 its mass into the speed of that fellow is 0.26. 0.26 square. Check the two values. E1 is 9.245 or 9.25 into 10 to the power minus 3 joules. E2 is half into 0.11 into 0.28 square plus half into 0.13 into 0.26 square. That is 8.7 into 10 to the power minus 8.71 into 10 to the power minus 3 joules. What do you think? Is it an elastic collision? 9.25 10 to the power minus 3 drop into 8.71 10 to the power minus 3. So the kinetic energy is not conserved. So you can say it is not an elastic collision. Write the statement. The kinetic energy of the system is not conserved. kinetic energy of the system is not conserved. So it is not an elastic collision. Yeah, you can say it's an inelastic collision. Okay. Then the next part is telling you, explain the assumption made when applying the principle of conservation of momentum to collision. So when applying the conservation of linear momentum, it is applied for what? For what? For a closed system. What is a closed system means? There are no external forces acting. Okay. So guys, for an example, let's say I push this calculator towards this remote and I make a collision. I can't expect the momentum to be conserved because definitely there is friction on this table. Okay. If there is air resistance, we can't apply principle of conservation of linear momentum. It will not work 100%. So where is this principle of conservation of linear momentum applicable? Where will it work? In a closed system. So what is meant by a closed system? There are no external forces acting. There's no external forces such as friction, air resistance acting. So here when you have applied the conservation of linear momentum, what are the assumption or what is the assumption that you have made, right? It is a closed system. It is a closed system. And there are no external forces acting on the objects. There are no external forces acting on the objects. Yeah, that's enough. Okay. Anything more for homework? That's all. Nice. Right, guys, get back to the theory. Okay. Right. So last subtopic that we have done is elastic collisions. Let's continue from there. Write down the next subtopic. Kinetic energy in terms of momentum. Kinetic energy in terms of momentum. Okay. Guys, now let's say there is this object which is moving at a velocity v, at a speed v, and having a mass m. So its momentum will be P equals mv. Am I right? Its kinetic energy will be E equals half mv square. Okay. Now from P equals mv, if I get the v subjective, v equals P over m. So now if I get that v equals P over m and substitute into this one, E equals half m, the v I will replace with P over m, and that square. Take off the brackets. Half m, P over m square will be P square over m square. So the kinetic energy is equal to, one of these m's will cancel off with this m. So you will be getting E equals P square over 2m. So this is the relationship between kinetic energy and the momentum. Kinetic energy of an object E is equal to momentum P square over 2m. Okay, take it down. That there's a half here, right? So this, it becomes m and m cancels off. There's a p square remaining here. There is this 2 remaining here. And there is an m remaining from the denominator. So it becomes p square over 2m. Okay. Right. Guys, write down the question. An object of mass 3 kilograms has a momentum of 12 kilogram meters per second. Has a momentum of 12 kilogram meters per second. Full stop. Calculate its kinetic energy. Calculate its kinetic energy. So guys, simply you use E equals P square over 2m. So the momentum is 12 square over 2 into m is 3. So 12 square over 2 into 3, that is 24. Is it? 24. Right, and the next one. An object of mass 5 kilograms. An object of mass 5 kilograms has a kinetic energy of 8.1 joules. Has a kinetic energy of 8.1 joules. Full stop. Calculate its momentum. Can you?
9, sir.
Right? So we use the same equation, E equals p square over 2m. So we have to find the momentum now. So I'll cross multiply, p square equals 2m into E. Correct? So p square is equal to 2 into the mass is 5. E is 8.1. So p square is equal to 81. P is equal to square root of 81, which is 9 Newton seconds. Sorry, or kilogram meters per second. Done? Right, okay. So guys, that's about momentum and kinetic energy. Write down the next subtopic. Angular displacement. Angular displacement. Angular displacement. Then now tell me, to what you know, angle is measured in what? Degrees. From small days, we have been measuring angles in degrees. Is there another unit to measure angle? Yes.
Irradiant.
Radians. Have you heard of it?
Yes.
Radians. So there is a relationship between degrees and radians. What is the relationship? What is the connection between them? Pi radians. Pi radians is equal to 180 degrees. That's the connection between radians and the degrees. Okay. Correct, right? So angular displacement is, guys, when an object is moving in a circular path, in a circular arc. So now let's say this is the center of the circle. Now let's say the object is moving in a circular path. Let's say it's moved from here to here. Okay, moves in a circular path, starting from this point to this point. So it has a particular center. And with respect to that center, there is a certain angle it is making. The angle that it is traveling. That is what you call the angular displacement. Okay. So it is measured in what then? It's measured in angle. So the unit that is used is radians. Okay. Now you're moving. Let's say you have a car or a bicycle and you start moving in a circular path, in an arc. So there is a particular center for that circular path. This is the center. Okay. So with respect to that center, there is a certain angle that you're moving. That angle that you're moving is what you call the angular displacement. Simple as that. So the angle is measured in radians, not in degrees. Draw this diagram. Show that the speed is v and the angle is theta.
So we learned something like this in O levels, IGCSE.
Okay. Right, guys. Right hand there. When an object is moving in a circular arc, when an object is moving in a circular arc, the angle moved, the angle moved is known as, the angle moved is known as the angular displacement, is known as the angular displacement. Full stop. It is measured in radians. Is measured in radians. Okay, within bracket just mentioned sometimes degrees or degrees. Right. So guys, the relationship between them will be, you can take it down. Pi radians. Pi radians is equal to 180 degrees. Okay. Right. Guys, write down a question. Convert the following angles in degrees to radians. Convert the following angles in degrees to radians. Right. So guys, we know 180 degrees is pi radians. So 180 degrees is pi radians means 90 will be what? Pi over 2, no? So it will be pi over 2 radians. Correct? Can you try the remaining? (45 degrees, 20 degrees, 30 degrees, 50, and 360. Okay. So guys, 45 degrees will be pi over 4 radians, no? Agreed? So 20 degrees means, now here see guys, 180 is pi means 1 degree will be pi over 180 radians, right? Correct? 180 degrees is pi radian. So 1 degree is pi over 180 radians. So 20 degrees will be 20 into pi over 180. Correct? Which will be pi over 9 radians. Check your answers. Correct? Similarly, 30 will be 30 into pi over 180. That will be pi over 6 radians. Okay. 50 will be 50 to pi over
18.
Yeah. 5 pi over 18 radians. If you want, you can give the decimal answer as well. 5 pi over 18 will be 0.873. 0.873 radians. Correct? So what is 360?
2 pi.
2 pi. Is that okay? Yes. Any questions? Right. Right on the next subtopic. Angular velocity. angular velocity. Or sometimes we call it the angular speed also, within brackets omega, denoted by omega. Guys, what is velocity?
So is there a W?
Omega.
No, I mean, it's like, is it W or is it connected? The top lines.
It's like this. This is omega. Okay. What is velocity?
Displacement over time.
Displacement made in a unit time. What is the displacement you make in a unit time? That is the linear velocity. Then what is angular velocity? Okay. What do you think is angular velocity? Angular displacement over time. How much angular displacement you are making in unit time, isn't it? Angular velocity. That means what is the angular displacement you are making in a unit time? So that is angular displacement per unit time. So right under that. It is the rate of change of. It is the rate of change of angular displacement. It is the rate of change of angular displacement. Full stop. That is the angular displacement made per unit time. That is the angular displacement made per unit time. Okay, guys, draw this diagram.
Sir,
Yes.
in the future, sir, like, the first foreseeable future, will you be changing time? Because like 9 o'clock there is around 6:30 here, so
6:30. Till only
Yeah.
6:30.
yes.
You can go until 5:30. I think that's fine. Yeah. I most probably I won't change the time. In case if I'm changing, it will be like another 15 minutes earlier. Can be a change like that.
No,
No
no,
major-
I mean later, not earlier.
Huh?
I mean, I want you
Yeah.
to increase, like, change the time later, not earlier.
No, that will not happen. That's something I have never done. I don't think it will happen.
So earlier becomes worse, sir. Don't do it, sir. Just keep the time.
No. Earlier the better.
No, sir.
So guys, mark in your diagram, the radius is r, angular velocity is omega, angular displacement is theta, the time is t. So the equation will be omega equals theta over t. Angular velocity equals angular displacement over time t. Correct? Right. Now, guys, let's say there is this object moving from this point to this point. Okay. It has a speed v. It has a speed v. That means distance it is moving per unit time is V. Okay. How much ground it's covering per unit time in terms of meters. Let's say that is V. And this distance will take it as, this arc length will take it as S. Okay. We'll take that arc length to be S. Then the arc length is given by, this arc length S is given by R theta. Did you know that? Those who are doing maths, I think you know it. Arc length is equal to this radius into the theta. S equals R theta, where the theta is in radius. That is the arc length. Draw this diagram and take down this one. Okay. S equals R theta. Right? Mark that time is T. Radius is R. Now guys, look at this. V will be equal to S over T. Yes or no? V is the speed. No? Speed is equal to distance traveled over time taken. So V will be equal to S over T. Agree? And then if I use V equals S over T, if I replace the S with R theta, it will be R theta over T. Correct? What is this theta over T? What's theta over T? Angular velocity, omega. So that means V is equal to R omega. So there's a famous relationship between the two speeds. One is, you call it the tangential speed or the instantaneous speed, which is V, the regular speed that we talk about. The omega is the angular speed or the angular velocity. So what is the relationship between the tangential speed and the angular speed is V equals R omega, where R is a radius. Understood? Take it down. Yeah, I'll repeat, just take it down. Right, guys, now what I told is, this S is equal to, arc length is equal to R theta, that is a theory. This arc length is equal to radius into this theta, where the theta is in radius. So that is the relationship, S equals R theta. Okay, And then v equals, v is the speed, the regular speed that we speak about, which we call as the instantaneous speed, or you call it the tangential speed. Why is it known the tangential speed or the tangential velocity? It is along the tangent of the circular path. That's why you call it the tangential speed or the instantaneous speed. So if you take that, that is equal to distance traveled over time taken. So the distance traveled is s, the time taken is t, so it will be v equals s over t. There's nothing new in that. That's something you know from your small grades. Speed equals distance over time. So how I connected them is, if v is equal to s over t, this si can now replace with r theta. So the si replaced with r theta. So v becomes r theta over t. Correct? And the theta over t, this part, what is that? That is angular velocity. So that theta over t I'm replacing with omega. So it becomes v equals r omega. Is that okay? And label the terms. V is instantaneous speed. V is instantaneous speed. R is radius. R is radius. Omega is angular speed or the angular velocity. Done? Right. Right, now the next subtopic, time period. Time period. Right, it is the time taken for an object moving in a circle. For an object moving in a circle to make a complete revolution. To make a one complete circle. It is the time taken for an object moving in a circle for an object moving in a circle to make a complete revolution. Okay. Right. So guys, let's say there's an object which is moving in a circular path with an angular speed omega. Let's say it takes a time capital T to make one complete round. So if I use omega equals theta over t, when it is making a complete circle, what is the angular displacement it's making? Two pi radians. So the omega will be equal to 2 pi over the time taken is capital T. Okay. So the time period T will be given by 2 pi over omega. Take it down. Right, guys, write down a question. An object makes an angular displacement of. An object makes an angular displacement of 2.2 radians an object makes an angular displacement of 2.2 radians in 4 seconds. In 4 seconds. Full stop. Calculate its angular velocity. So very simple, just a matter of substitution. Omega equals theta over t. Theta is 2.2. Time is 4. That is 0.55. Guys, what is the unit? Radians per second. Radians per second. Angular velocity. Right on the next one. Question 2. An object moves at an angular velocity of. An object moves at an angular velocity of 0.8 radians per second. 0.8 radians per second for 3 seconds. Full stop. Calculate the angular displacement. Calculate the angular displacement made by the object.
Two 2.4. Right.
So it will be again omega equals theta over t. So if we cross multiply, theta equals omega into t. So omega is 0.8, t is 3. So theta equals 2.4 radians. Okay. Right. Right on the next one. An object moves at an angular velocity of. An object moves at an angular velocity of 0.4 radians per second. An object moves at an angular velocity of 0.4 radians per second. Full stop. Calculate the time period of the object. Calculate the time period of the object.
So do you have to give the answer in pi or in decimals?
Time period, no, it give in decimals. So it will be
15.7.
omega equals 2 pi over t, right? Angular velocity is 0.4. 2 pi over the time period is capital T, what we have to find. So capital T equals 2 pi over 0.4. That is 15.7. Okay, fine. Guys, we'll do one question and then take a break. Take the tute. Question number 6. Can you give a try? I'll give you 5 minutes. You give a try first. Question number 6 from the tute. Right, okay. The player swings her stick so that the heel moves horizontally in a circle of radius 0.8 meters across the ground. Okay. It takes time of 0.22 seconds for the heel to move through an angle of 1.3 radians. Calculate the speed of the heel. So guys, I can take the omega equals theta over t. Theta is 1.3 radians. Over the time taken is 0.22. This gives you the omega, which is 1.3 divided by 0.22. I'll take it as 65 over 11 for now. This is the angular speed. But we have been told to find the speed. So which is, I can use V equals R omega. R is 0.8 into the omega is 65 over 11. Which is 4.73.
So why can't you just use V is equal R theta over T?
Can, no harm.
Yeah,
You can,
it's shorter.
you will get the answer 4.73 anyhow. Okay. The next one, part B. A ball has a speed of 13 meters per second. The heel has a momentum, P heel, of 3 Newton seconds in the direction of the dashed line as shown. The heel collides with the ball and stops. The speed of the ball after being hit by the heel is 60 meters per second. Deduce whether the momentum is conserved for this collision by completing the vector diagram. A scaled line representing the P heel is shown. The mass of the ball is given 160 grams. Do you understand this diagram? Now guys, the ball is coming from here. The ball is coming in this direction. And then you bring the heel and hit it. And then the ball changes its direction. It moves this way. Correct? The ball comes in one direction. You hit it so that the direction of the ball changes. So in which direction did you move the heel? The heel moved in this direction. Ball is coming this way, you move the heel this way. That's what happened. So right after you hit the ball, the heel stops. The heel collides with the ball and stops. Okay. So the question is what? Deduce whether the momentum is conserved for this collision by completing the vector diagram. A scaled line representing the P heel is shown. The mass of the ball is given 160 grams. Anyone who got an answer? Right. So before the collision, the momentum of the heel is given 3 Newton seconds. Guys, can someone please measure this length and tell me how much is that length? 6 centimeters, is it? Is it 6? So which means the scale that they have used is 1 Newton second is equal to 2 centimeters. Correct, no? 3 Newton seconds, they have represented with 6 centimeters. So which means 1 Newton second is 2 centimeters. So the ball has a mass of 0.16 kilogram. So guys, I'll calculate its momentum before the collision this way. P1, 0.16 into 13. 0.16 into 13 will be 2.08 Newton seconds. Here I will calculate the momentum P2, 0.16 into 16. That is 2.56 Newton seconds. Okay. So this angle is 56 degrees. So I'll start from here to represent that one, 56 degrees.
So if you do the opposite side also,
So,
it's same
yeah,
thing,
no
right?
problem. As long as I want to see
Yeah.
whether if I'm getting a closed vector triangle. So I'll take 56 degrees. At 56 degrees, I'll draw a length of 2.08 Newton seconds will be how many centimeters, guys? 2.08 Newton seconds will be
4.16.
4.16 centimeters. So I'll exactly at an angle of 56 degrees, I will draw a line of 56 degrees. Sorry, 4.16 centimeters. Okay. And then I will connect these 2 points. And this 2.56 Newton seconds should be how many centimeters?
5.12.
5.12 centimeters, right? So what I'll do is I will connect these 2 points and I'll measure this length and see if it is anything closer to 5.12 centimeters. You get what I'm saying? So
Yeah.
I will connect these 2 points and measure and tell me what is that length you are getting. What's that length? 5 point? Correct? If that is the case, then definitely yes, you can write the conclusion saying the above vectors gives a closed vector triangle. The above vectors gives a closed vector triangle. Sorry. So the momentum is conserved. Okay. So the momentum is conserved. Right. And the last part, deduce whether the collision is elastic. Speed of the heel before the collision is given 5 meters per second. So what is the mass of the heel? Do we know the mass of the heel? We can
No,
find
so we
it.
have to find it.
Yeah, we know the momentum of the heel by using P equals mv. Momentum of the heel is 3. Mass into the velocity is 5. So the mass of the heel is 0.6 kilograms. Correct? Right. So guys, before collision, the total momentum is if I take it, sorry, total kinetic energy is, if I take it as E1, the momentum of the heel is half into M is 0.6 into V is 5 square plus the momentum of the ball is, sorry, the kinetic energy of the ball half into 0.16, half into 0.16 into 13 square, into 13 square. This is the total kinetic energy of the heel and the ball before the collision. After collision, the total kinetic energy will be E2 half into, the heel doesn't have a kinetic energy, it stops. So the ball's kinetic energy will be half into 0.16 into, its speed is 16 square. Let's compare the two values and see.
No, so there's a big difference. Sir. First it's 8.54 and then second is 20.48.
No, the first one I'm getting 21.02. 21
Really?
joules. Second one I'm getting 20.48 or 20.5 joules. It's a tough call. Are you getting these two values? Guys online, are you getting? Yeah.
Yeah, yes, yes.
Mass 0.16 only I have taken for the ball. 0.6 I have taken for the heel. So before the collision, you have to consider the kinetic energy of the heel and the ball both. After the collision, the heel doesn't have a kinetic energy. Only the ball has a kinetic energy.
So it's almost similar, right? Only 0.5
Yeah.
difference.
So I feel like you can put it both the ways. One can say there is a loss in the kinetic energy, so it is inelastic. One can say the kinetic energies are almost the same, so it is elastic. So, but I will, to be on the safe side, my answer will be it is inelastic. There's a drop of 0.5 joules. So, guys, you can scan the barcode at the bottom of the page. It will tell you from which paper is this question. Okay, this will be, you'll have the barcode reader.
Yeah.
This is this is 2022 October. And then you can check the marking scheme. Yeah, this is 2022 October paper. I mean, 2022. Yeah, 2022. Anyway, write the answer. There is a drop, there is a loss in kinetic energy during the collision. There is a loss in kinetic energy during the collision. So it is an inelastic collision. Right. As you can go for a break. See you in 15 minutes. Okay, guys, get back to work. Right on the next subtopic. What other there? What is the name? Huh? Centripetal acceleration. Centripetal acceleration. Okay. Now, guys, when an object is moving in a circular path, okay, even though it is moving at a constant speed, even if it is moving at a constant speed, its velocity is not constant. Right? Velocity is not constant. Speed is constant, but the velocity is not constant. Why is the velocity not constant? Because its direction is changing. Correct? Velocity is not constant, even the speed is constant because the direction is changing. So that means the velocity is changing now. So the velocity is changing means it is accelerating. Change in velocity is acceleration. So when an object is moving in a circular path, even if it is moving at constant speed, still it is accelerating. So that acceleration you call it what? Centripetal acceleration. And that acceleration will be always towards the center of the circle. Understood? Right under that. When an object is moving in a circular path, when an object is moving in a circular path, when an object is moving in a circular path at a constant speed, when an object is moving in a circular path at a constant speed, its velocity keeps changing. Its velocity keeps changing since its direction is changing. Since its direction is changing. Full stop. So the object is accelerating. So the object is accelerating. Full stop. This acceleration is known as the centripetal acceleration. This acceleration is known as the centripetal acceleration. And it is always directed towards, and it is always directed towards the center of the circle. And it is always directed towards the center of the circle. Right, guys, draw this one. Okay. Right, guys, draw this diagram. Guys, draw this diagram. An object moving in a circle, angular velocity is omega, instantaneous speed is v, and the radius is r. Mark it on a diagram. Right, so guys, in that case, where an object is having a speed v and an angular velocity omega, its centripetal acceleration is given by a equals v square over r. Take it down. Centripetal acceleration is given by a equals v square over r. Okay. What is the relationship between v and omega? What is the relationship between v and omega?
The radius.
V is equal to r omega. So guys, if you replace this with v equals r omega, then we will get another relationship. V, if you replace with r omega, it will be r square omega square over r. Then you get another equation for the centripetal acceleration in terms of omega. A equals r omega square. Take down that as well. So guys, centripetal acceleration, the same centripetal acceleration has two equations. One is in terms of the instantaneous speed, a equals v square over r. The other one is in terms of the angular speed, a equals r omega square. Both are used a lot. Write down a question. An object is moving in a circular path. An object is moving in a circular path. At a speed of 8 meters per second. At a speed of 8 meters per second. And a radius of 2.5 meters. And a radius of 2.5 meters. Full stop. Calculate its centripetal acceleration. What's the answer? So centripetal acceleration,
25.6.
we can use A equals V square over R. V is 8. 8 square over R is 2.5. How much is that?
25.6.
25.6 meters per square seconds. That is the centripetal acceleration. Is that okay? Maybe another half an hour. Okay. Right on the next one. 11:15. Right on the next one. An object moves in a circular path. An object moves in a circular path at a speed of 6 meters per second. At a speed of 6 meters per second. And a radius of 80 centimeters. And a radius of 80 centimeters. Full stop. Calculate its centripetal acceleration. Calculate its centripetal acceleration. Give me the answer. An object moves in a circular path at a speed of 6 meters per second and a radius of 80 centimeters. Calculate its centripetal acceleration.
45 meters per second squared. Right. So guys, A equals once again V square over R. V is 6 square. The R is 80 centimeters, which is 0.8 meters. How much is that? 45 meters per square second. Right on the next one. The last one for the day. An object moves in a circular path with a radius of 2 meters
with a radius of 2 meters and an angular velocity of 2.5 radians per second. 2.5 radians per second. Full stop. Calculate its centripetal acceleration. Calculate its centripetal acceleration. So guys, now you have the the angular velocity. So we use A equals R omega square. R is 2. Omega is 2.5, that's square. So A equals how much? 12.5 meters per square seconds. Okay. Right, guys, let's continue from here on the next day, but wait. Mark these questions for homework. Question 5. Question 10. Guys, in question 10, listen. Now the first part is proving this equation that we haven't done yet. So you can skip that first part A, and do the remaining parts. The first part is asking you to prove the equation A equals V square over R that we haven't done it yet. We will be doing it next week. So that part you can skip and do the rest. Question 12. 12, 14,
So we will be finishing unit 1 before the January exam session.
unit 1.
I mean unit 4.
Yeah, unit 4 will be done before January, you're asking me.
Yeah.
Definitely yes.
Okay.
Okay, guys, try those questions from homework. We'll continue from this point on the next day. Bye, people. See you next week. That's it for the day. Have a nice week ahead and do the questions most important. Bye. See you. You're welcome. Bye. See you.